Let's say I have a program where I want the user to enter their age, and it tells them how old they will be in 10 years. So I want to take their age, whatever they enter it. I know they don't need a program to tell them this, but let's just say they do. So I'm going to take their age as input. I need to convert it to a number, right? Because if I don't, when I add 10 to it, I'm going to get an error. And then I'm going to print that out using an F string. So if I say strAge equals input, how old are you? Now I'm going to convert that to a number. Int age equals int strAge. And finally, I'm going to print out how old they are. Okay, I'm going to print in 10 years, you will be. And I can actually, in an F string, I can put a simple expression like this, like int age plus 10. Okay, that'll print out their age in 10 years. So if I run this, 10 years, 50, in 10 years, you will be 60. Cool, works great. Easy, simple program. But now, let's say I am going to type that in, which means the same thing, but it's not a number. So when I run that, it's going to give me an error because I can't convert that to an integer. So here's an interesting way that we can use loops to fix that. So here's what I'm going to do. I'm going to go back up to the top, right here, and I'm going to add a line above it, and I'm going to say, while true. So we're going to do this forever. What are we going to do forever? Well, we're going to ask them how old they are forever until they give us a number, that we can use. So here's what I'm going to do. I'm going to say if strAge dot is numeric, right? Because that's tests. That's a test to see if that string contains only digits. If that string is numeric, then what am I going to do? If it's numeric, they did the right thing, and I'm going to break out of the loop because they gave me what I wanted. If they don't type a number, then what am I going to do? I'm going to give them a little bit of feedback. I'm going to say print, you must enter digits only. And because I didn't break out of the loop here, if they don't enter digits, it's going to say you must enter digits only, and then it's going to go right back and ask them again. And it's going to keep asking them that question until they give me the right kind of answer, and then it will move on and do the calculation. So now I've made this program not crash proof, but I've made it a little bit better, a little bit stronger to get what I want. So now, how old are you? If I type the word 50, it says you must enter digits only. And it's literally, no matter what I type, if I'm not entering only digits, so if I say 10.5, it will say enter digits only. As soon as I give it what it wants, which is only digits, it goes on and gives me the answer. So that's a real practical way. And by the way, this is a design pattern. And when we're in programming, there are common design patterns, we call them, in our code. It's a way of doing things that is commonly used throughout our programs. So this is a design pattern where we can use this over and over and over in different contexts to make sure that the user is giving us what we want. And when we get to error handling in the class, what you're going to learn is that this is called look before you leap error handling, meaning you want to make sure before you try to do that conversion to an integer that you're actually dealing with the right data. That's one way to handle it. So this is a design pattern that I want you to think about and remember, because you're going to see it again throughout the class. So let's take a look. Here's another practice. What we're going